All right, so this is our next example, and we're going to try to write a trig function that models this graph, right? So this is a little different now because the graph seems to be shifted horizontally and vertically, and we have to work through that part. So the first thing I like to do in this case is it's good sense to get your line of oscillation sketched in here just to help you make sense of this image. So I have 2 points right here and here that are identified, 1.19, comma 2, and then 4.261, comma 2. So these 2 points will allow me to find the period, which we'll get to in a minute, but really we're talking, what we want to look at is, this high point here, and then, here's a low point right here, right, at -4. So K value, like your line of oscillation, it's the it's going to be max value plus the mid value divided by 2. That's going to give us our K value. So basically here what we're doing is the max value is 2. The minimum value is -4. I'm going to divide this by 2. That's going to equal K. So that's going to leave us with a value of, -2 divided by 2K equals -1 right now, which is critical because this is going to be a value in our equation. So I'm going to sketch that in right there. So there's a visual for us at this point. That's the line of oscillation. The next easiest thing to do is find the amplitude, right? So your amplitude is measured from the high point to the low point right here. So if the K value right now is equal to 2, then that distance is the grid measured from that Y value down to this Y value at 2, -1. Went from K is 2. Right, so that the amplitude now is 3, and we can identify that as well. At this point, people start thinking, okay, do I want to write sine or cosine? And if you struggle with that, then maybe you can move into the period, but we're going to try to determine, do we want to do a sine function or a cosine function at this point? So you want to look for points that are helpful here, right? Remember, your sine function starts at the line of oscillation and runs like this. Cosine function starts at a high point here and runs like that there. So I have a high point right here. I have another high point right here. The K value, right? If you think about it, for sine, not the K value. The sine function starts on the line of oscillation. So that would kind of be like right here, moving up. But I don't know what this coordinate point is. I don't really have the easy way of identifying it right now. So logically, it makes more sense to use a cosine function, red here, to start at this point and then just kind of run down. What we'll do is we'll adjust our starting point. So once you kind of make sense of that, then we're going to identify that we're going to try to write a cosine function here. All right, and then since I identified cosine, I need to find that horizontal shift. Since I have this x coordinate right here, 1.119, I'm going to make my h value here where we start the beginning of the cosine wave, right? Next up, it's now time to look at the period, right? So period is measured at the start of the wave to the end of the wave. So if we're going to start our wave here right now, it makes sense to measure your period right here. And you can use these two x values right here to do that. So we're going to take the difference between those two x values and find our period value, right? So our period right now is going to be 4.261 minus 1.119. 4.261 minus 1.19. Grab your calculator, take that calculation. 4.261 minus 1.11 equals 3.142. It's very close to pi. 3.142 right now. We're going to leave it at 3.142 at the moment, and then I have my period. Once you've identified your period, it makes the most sense to now move into finding your angular frequency, which remember, your angular frequency is identified by the relationship period times angular frequency is always 2 pi. So then if my period is 3.142 times the angular frequency equals 2 pi, I'm going to divide both sides by 3.142. Grab my calculator now, calculate that. So 2 pi divided by 3.142. It's going to be really, really close to the number 2 right now. So in this case, we're going to say our angular frequency B equals 1.9997, which this really, due to approximations from the points given, really should be pi, but we're going to leave it at the angular frequency is going to be 2.0 at this point. So we try to round this. We're just going to round it to 2.0 right now. So I have my angular frequency, I have my period, but I don't put this in the equation. Got other critical values of my starting point, which is we identified as 1.119, and then my line of oscillation K up here. And we determined we're going to write a cosine function. So let's look at this. So we see the cosine. Our H horizontal shift is 1.119. Our vertical shift was the K value, so this is -1. And the period was 3.142. The amplitude we said it was 3. Amplitude is 3. And that's enough information to write this function now. So at this point, we're going to jump into writing the function rule, which is y equals a cosine b times x plus k. So in this case, it's going to be y equals 3 cosine of, and now you got to be careful here as you write this. Angular frequency is 2, and then we want to group x minus 1.119 close the group, and then plus that negative 1 value, minus 1. And that's our function. When we with these horizontal shifts here, we always want this angular frequency here to first be outside, and then in the group where the variable exists, that's where we do our subtraction and addition to the h value. And that's essentially this function equation right here to model this. Next example, we're going to look at how to write multiple different function rules for this.